Hi students. So we were discussing the topic enthalpies for different types of reactions. In that we have seen standard enthalpy of combustion, then enthalpy of atomization, and in the previous video we have seen bond enthalpy. So today in this video we'll discuss lattice enthalpy. So the lattice enthalpy of an ionic compound is the enthalpy change which occurs when 1 mole of an ionic compound dissociates into its ions in gaseous state. So you know what you mean by ionic compound, that is those which forms ions. Ions means having positive and negative charges, positive or negative charges. Those compounds are called ionic compounds. So when you take 1 mole of an ionic compound and when it dissociates, that is when it breaks down into its constituent particles, like into its ions, what is the change in enthalpy or the change in enthalpy during that process? That is called as lattice enthalpy. That is when you take 1 mole of an ionic compound and when it dissociates into its ions. Into its ions means into positive and negative charged particles, the change in enthalpy during that process is termed as lattice enthalpy. Now, if you consider this example, just consider this example of NaCl, okay, sodium chloride. It is an ionic compound. You can see it dissociates to give Na plus and Cl minus, that is ions, Na plus ion and Cl minus ions. And the lattice enthalpy is also given, that is 788 kilojoules per mole. Okay, so you can see this NaCl, this ionic compound, it dissociates into its ions in gaseous state. Both are in gaseous state. NaCl is in solid state, but their ions is in the gaseous state. Okay, so if you consider this example, it is impossible to determine the lattice enthalpy directly by experiment. Okay, you cannot find the lattice enthalpy of this particular reaction directly by experiment. So to find lattice enthalpy, you need an indirect method. You need to find the lattice enthalpy in an indirect method. To find the lattice enthalpy in an indirect method, we need to construct an enthalpy diagram, and that enthalpy diagram is called as Born-Haber cycle. Okay, so Born-Haber cycle means it is an enthalpy diagram, okay, to find the lattice enthalpy in an indirect method. Okay, now we'll see how to find the lattice enthalpy of NaCl. Okay, and for that there are certain steps to follow. Some 5 steps are there to find lattice enthalpy. Okay, so we'll discuss these steps next. Now the first one is this Na, that is sodium in solid state. Sodium is in a metal, it is in a solid state. That solid state, you need to convert it to a gaseous state. Okay, solid phase you need to convert to gaseous phase, because our aim is we need to get Na plus and Cl minus. Okay, Na is a metal. Okay, so it is in a what is a neutral state. So we need to get Na plus ion and Cl minus ion, then only we can combine them. Okay, so only Na plus and Cl minus we can combine. So we need to get Na plus and Cl minus. So to get charges we need gaseous state. Okay, so first convert solid state to gaseous state. You know that solid to gaseous state directly, it is sublimation. So here you need to calculate sublimation of sodium metal, that is delta sublimation enthalpy. Enthalpy for sublimation you have to write, that is 108.4 kilojoules per mole. That is the first step. Now the second step is this gaseous sodium. What you have to do is you need to remove an electron so that you will get Na plus charge. So to get plus charge, you know that you need to remove an electron or you need to donate an electron. When you give one electron, you will get plus charge. So you need to remove one electron. So to remove an electron, that element should be in their gaseous state. So we need to convert solid to gaseous state. Okay, so you know that when you remove an loosely bounded electron from a isolated gaseous atom, that energy is called as ionization enthalpy. We have already studied ionization enthalpy is the energy required to remove the most loosely bounded electron from a gaseous isolated atom. Okay, so here to remove an electron you need ionization enthalpy, and that is the ionization of sodium atoms, and it is given ionization enthalpy is 496 kilojoules per mole. Okay, and this ionization enthalpy, it is actually the term from thermodynamics. Okay, now the next step, third step is you need to take chlorine. So chlorine, it is Cl2. Chlorine is always a diatomic molecule. Cl2 it won't exist in Cl. So half is written to balance the reaction, because we need only one Cl, Na plus and Cl minus it is. So for that you need to write half Cl2, so that 2 and 2 if you cancel, it is Cl, just Cl. But Cl won't exist as Cl, it is always Cl2. So to balance that you need to write half. So Cl is already in a gaseous state because chlorine gas it is. So what you have to do is Cl2, it is a molecule. Okay, so you need only one atom of Cl. So Cl, what you have to do is you need to break the bond and make them atoms. Okay, so to break the bond you need bond dissociation enthalpy, or the dissociation of chlorine. The reaction enthalpy is half the bond dissociation enthalpy, isn't it? So you need bond dissociation enthalpy there. You have to consider bond dissociation enthalpy, and it is given as half delta bond dissociation enthalpy, that is 121 kilojoules per mole. Half is written because we have written half Cl2, it is to balance, so you have to take half the bond dissociation enthalpy, and that value is 121 kilojoules per mole. And this 121, again you don't need to divide by 2, already that value is divided by 2 and you got that value as 121 kilojoules per mole. Okay, now the fourth step is what you have to do is chlorine, that you got chlorine in gaseous state, is chlorine atom in gaseous state. Now you need Cl minus. To get minus charge, what you have to do, you need to accept an electron. Okay, so chlorine will accept one electron and will give Cl minus in gaseous state. So that is electron is gained. So to gain an electron you need energy, right? You'll release energy, that is electron gain enthalpy, that is also you have already studied. Okay, so electron gained by chlorine atoms, and electron gain enthalpy is given as minus 348.6 kilojoules per mole. It is written as minus because it is an exothermic reaction. When an atom or when an electron is added to an atom, energy is released. It is an exothermic reaction. So the value is minus 348.6 kilojoules per mole. And the last step is what you have to do is, there you got Na plus in gaseous state and here you got Cl minus in gaseous state. Those both of that you have to combine and you will get Na plus and Cl minus. That is actually bond formation. Okay, bond enthalpy change for formation of a compound, and that value is also given as minus 411.2 kilojoules per mole. Okay, so after this, all these steps, that is sequence of steps, it is shown in a Born-Haber cycle. So we'll discuss that. So this diagram is called as the Born-Haber cycle, or this is the enthalpy diagram for lattice enthalpy of NaCl. So this this you have to begin from the left hand side. Second step, that is sodium in solid state plus half Cl2 in gaseous state. When you combine that you will get NaCl. Okay, that is actually the reaction. Na plus plus half Cl2 gives NaCl. Okay, so from there, first what you have to do, sodium in solid state you need to convert it to gaseous state. So there it will come delta H sublimation, that is enthalpy of sublimation, and half Cl2 in gaseous state you have to write it as it is. Okay, then next step is this Na in gaseous state you need to remove an electron and make it Na plus. For that you need ionization enthalpy, and that is written as delta IH, that is ionization enthalpy, and that value is given for 95.6 kilojoules per mole. And this half Cl2 you have to write it is. Then after that, once you get Na plus, now our aim is you need Cl minus to combine. So from half Cl2 what you have to do is you need to dissociate the bond and make it atoms. It is a molecule now, Cl2. So you need to dissociate and make it an atom. For that what you have to do, you have to use bond dissociation enthalpy, break that bond, you will get a bond dissociation enthalpy. That value is given as 121 kilojoules per mole. Then you will get Na plus and Cl atom in gaseous state. Then the next aim is you need Cl minus to combine with Na plus. So to get Cl minus you need to Cl minus Cl should accept one electron. So you will get you need to accept an electron, that is electron gain enthalpy. It is given as delta Eg. Okay, electron gain enthalpy, and you know that value, that process is an exothermic process, and the value is minus 348.6 kilojoules per mole. And then you will get Na plus and gaseous state, and when they both combine you will get NaCl. And last you can see delta lattice given. The lattice enthalpy is actually the energy required to dissociate NaCl. Okay, so that value actually you have to minus. And this side, in the left hand side, the first step you can see Na plus plus half Cl2, that is the proper reaction. You will get NaCl downward, and that is called enthalpy of formation, and it is written as minus 411.2 kilojoules per mole. Okay, now what you have to do is this there is an equation to calculate. Now what you have to do is this bond enthalpy for the formation, that will be equal to enthalpy of sublimation, enthalpy of ionization, then bond dissociation enthalpy plus electron gain enthalpy minus lattice enthalpy. And from that you have to take only delta lattice enthalpy, and you will get values like this. All these values you have to add. Okay, all the values when you add, you will get delta lattice enthalpy, that is plus 788 kilojoules. This is how you calculate the what you say lattice enthalpy in an indirect method, because you cannot measure it directly by experiment. So this is how you find, and this is called as the Born-Haber cycle. Okay, now for from this value of lattice enthalpy, you can calculate the enthalpy of solution. Okay, and that expression is given as delta enthalpy of solution is equal to lattice enthalpy plus hydration enthalpy. That is the formula. Enthalpy of solution is equal to lattice enthalpy plus hydration enthalpy. Lattice enthalpy we got in an indirect method, that is 788 kilojoules per mole, and the hydration enthalpy, and it is given from the literature, that is minus 784. When you substitute these values, you will get 4 kilojoules per mole as the what enthalpy of solution. So that the dissociation of NaCl, it is just accompanied by a very little heat change. Thank you.